Welcome to another video in the NetWorker training series. In this video, we will be looking at the device properties. So there are a number of devices that can be configured or created on NetWorker, and all the devices have a pretty much common device properties. So that is why I have created this video before I could go ahead and show you how to create or configure different kind of devices in NetWorker so that you understand these properties that would help us to understand the configuration of each of the devices more in detail. So before we go into the actual properties of the devices in NetWorker, there are a few terms that I want you to be familiar with or have a better understanding of. The first is a data stream. So what exactly is a data stream in NetWorker? A data stream includes a backup data stream, a SaveFS process, or a probe job. So any kind of stream that is coming from a client is called a data stream. The next parameter that is important to know is the parallelism. So parallelism defines the number of data streams that a client can use simultaneously during a backup. So what exactly does this mean? So if you look at the image here in this slide, we see that there are a number of streams coming from a machine, a backup, or a client machine. A client machine, as you know, is a machine that generates backup data, and this backup data is sent to the target device in streams. So every stream or the number of streams created depend on the save sets that are defined for that particular client, and the parallelism governs how many of these streams can be sent to a target at the same time. So by default, a client has a parallelism of 4, which means that when a backup initiates, it can send 4 streams from that particular client to a destination. It could be any kind of device that we use in NetWorker. So if you are not able to understand this, please rewatch it. So data streams and parallelism. So why do we need to understand those two terms, that is data stream and parallelism, for device properties? Because as I already told you, a data stream is a stream that is generated from the client, and parallelism is the factor that governs the number of streams that are allowed to be sent from a client to a device at a given point in time. In the same way, on the device, we have a parameter called target sessions, which governs how many sessions or how many streams a device can take in at a particular point in time. So the target session is not the only parameter which governs the number of sessions that are taken in by the device. There is another parameter which we'll see in the coming slide. So when you go to any device and right click on that device and select the device properties, this is the window you're greeted with. So there can be chances that you might not be seeing all these tabs, which might be because of the diagnostic mode not enabled on the NMC. So if you want to look at all these tabs, all you have to do is go to the NMC, go to view and select diagnostic mode, and then again when you come and select the device properties, you will be able to see all these tabs. So now on your screen right now you have the general tab. So in this session we will be talking about just this general tab and the configuration tab, because those are the important tabs wherein all configurable items are available as far as your devices are concerned. So now under the general tab, the first section that you have is the identity, and under identity you have the first parameter, which is the name of the device. For an AFTD or a data domain device, the name of the device is just a simple string which will help you to identify a particular device. If in case it is a tape device, then it is the complete path or a path to the file that is controlling the device on the operating system. Comment is whatever comment you want to put in explaining the use of the device, or you can put in information related to which pool it belongs to, or which location or which data domain it uses, and so on and so forth. It is up to you. The device access information is mainly useful for the AFTD or advanced file type device and a data domain device, and in this field you will find the complete path to the folder that this device is configured on. So on an AFTD, since an AFTD is a device that is created on an operating system, it will be the complete path to that particular folder on the operating system. It can have multiple entries pointing to the same folder, with which one can be the complete location on the operating system. The second can be complete network path to that particular folder, so that your client direct might be satisfied, so that in such a way that the client will be able to directly access that particular folder. In case of a data domain, it will be the name of your data domain and the complete path to the folder that is created on the data domain storage unit, and we will see how that looks like when we create a data domain device in the coming videos. So description again is something that you can put depending on describing the device that you want that you have. Another point about the name is that the name is read-only once it is created. So once a device is created, you will not be able to change the name of that device unless you delete and recreate it again. Next is the media type. So the media type is the type of media that is represented by this device resource. So in the example that you see on your screen, it is shown as it is an ADV underscore file, which means that this is an advanced file type device. Similarly, if it is a data domain device, it would have been listed as a data domain, and if it was a tape, it would have been mentioned of what kind of tape drive this is, an LTO2, LTO3, LTO4, 5, and so on. The media family is again the family to which the type of device belongs to. If it is a tape drive, it would have been mentioned as tape. If it is a data domain or an AFTD or an FTD, it be mentioned as a file, as a disk. Again, the media type is something that you select during the creation of device if you are creating it manually. So if you are using the wizard, you don't have to go through all these things, but once created, these this parameters cannot be changed. The next section here is the status. The first parameter or the first attribute is enabled, which has three options here: yes, no, and service. Yes means that the device is enabled, and once the device is enabled, NetWorker server is going to have an NSR MMD run towards this device on the respective storage node, and it will be available for any backup needs. The next option is no, which means that the device will be in an disabled state, which means that the device will not be in a condition of accepting any data streams for any of the targets, or either for read or for write. The service status is required in case you want to run some service or maintenance on your device. Mainly when you are talking about the tape drive, if you want to run a cleaning, you won't be able to run cleaning when the tape is already reading or writing data. So you can put it in service mode to make sure that whatever streams are being written or read from that particular tape drive complete, and no more read or write are done by that particular device. So next is the read-only option. When you select the read-only option, your status is enabled, the device will be available only for read operations. So the device will not be available for any write operations. So for backups, it will not be available. The next option here is auto media management. So auto media management in terms of a file type device is wherein if you unmount a volume from a device, and if there is a request for a device in the respective pool where this particular device belongs to, the volume will get automatically mounted and will be made available for that backup. again, the same scenario wherever there's a request for a volume to be read and that volume belongs to this device and it is unmounted, then this will automatically mount that particular device. So if you keep this enabled, you need not come and mount devices whenever they are required. So that is all about AutoMedia management. There is AutoMedia management available for tapes as well, but this particular AutoMedia management option is enabled on the tape library, so that the tape library is allowed to automatically uh, label and use unlabeled tapes whenever they are available in your jukebox. Next is cleaning. So again, this section is required only in case you are using a tape drive, and whenever your tape drive requires cleaning, this is going to be automatically checked. Or if in case you want to manually initiate a cleaning for that particular drive, you can select this, and the drive is going to initiate a cleaning if the cleaning is configured to be done automatically for that particular jukebox. Cleaning interval is generally defining a time interval for the tape drive to be cleaned, so it can be mentioned in terms of numerical and a period, which is numerical is an integer number 1 2 3 4 so on, and the period itself is days, weeks, months, year. And the next option just shows you when was the last cleaning done, if it was done for this particular device. The last option is suspected device. So suspected device is enabled whenever your storage node is not able to access this device, or if your NetWorker server is not able to access the storage node, which in turn owns this particular device. That is when the suspected device option is enabled. This happens whenever maybe your data domain is down or your tape library is down and you're not able to access that particular device. Then NetWorker automatically marks that device as a suspect, so that the backups do not use these or wait for these particular devices. So these were the important parameters under the general tab. So let's go ahead and look at the configuration tab. So in the configuration tab, as we already saw, we have something called as the target session. So again, the target session is the number of data streams that a device can handle parallelly. But this is not actually the maximum number of sessions or data streams that a device can handle. So one of the main questions that we often get while looking at the device configuration is the difference between the target session and the max sessions. So the max session mentioned here is 32 and the target session mentioned here as 4. So these two parameters help us to load balance between the different devices that belong to the same pool and the same storage node. So if in case you have multiple devices that are assigned to the same pool and to the same storage node, these two parameters are going to help you to load balance between those devices. For example, in here we have the target session mentioned as 4, which means that when this device is selected to be written, it will allow 4 sessions to be sent to it from whichever client it can be which is currently running. So once it receives these 4 sessions, it is going to stop processing any more data streams, and in turn it is going to allow the next device in the same pool to take in these backup streams, which allows the load balancing between the different devices. But if in case all of your devices in the pool or the storage node have reached the maximum number of target sessions, then any new incoming data streams are divided among all the devices until each device reaches the maximum session of 34. For example, if you have 2 devices in your pool which belong to the same storage node, you have 8 streams coming in, then the first 4 streams will be handled by device 1, the next 4 will be handled by the device 2. Now at this point, if there are 8 more streams uh, which are required to write to the same pool, to the devices which belong to a same storage node, then this will be divided between these devices, meaning after the 8th stream that is taken in by the second device, the ninth stream is taken by device 1, the 10th stream is taken by device 2, the 11th stream is taken by device 1 again, and so on. So the distribution of the stream is done one stream per device, and then again back to the first device, and so on and so forth, more like a round robin, until the total sessions that are consumed by a single device reaches 32. So the max sessions is the hard limit, and target session can be mentioned as the soft limit for a device, which means that once the target soft limit is reached, which is the target sessions, it is going to allow the other devices to take in streams. But once the hard limit is reached, which is the max sessions, it is not going to take in any more data streams until the existing or the data stream that it is already taking in completes and it has a free slot to take in more streams. Max NSRD count is the total number of NSR MMDs that can be spawned for a single device to allow the processing of data streams that are coming to this particular device. So the default number assigned to the NSR MMD count will be equal to the max sessions, which is 32, divided by the target sessions, which is 4, plus 4, which means that in this scenario it is 32 divided by 4, which is 8, plus 4, which is 12. Alright, so this can be changed, but this is the optimal number which is assigned to it by default, so I would recommend not to change this. So more the number of NSR MMD counts will be spawned, there is more the load on the storage node. The current NSR MMD count shows you the current NSRD that are spawned for this particular device. The section for media management is where in the volume default capacity is mentioned. We did not worry about this part. The second part, however, the AFTD percent capacity defines how much percent of the mount point wherein your AFTD folder is defined can be filled. For example, if you have it configured on your root system or a root file system, you can maybe mention that the AFTD percent capacity is 50%. That means that when the partition fills up to 50%, the AFTD will be marked as full and it will not take any more data into that particular device. So this is just a safeguard to help you control the filling up of the file system partition wherein your AFTD folder is created. So next is the verify label on eject. This is for the tape drives again. When a mount operation is done, the mount operation is more about placing the tape into the tape drive and then reading the label of the tape, which should complete the mount process. And whenever there is an eject, by default the tape label is not read during an eject, and if in case you select this option, the NetWorker server is going to read the label of the tape when it is ejecting as well. This is going to be time consuming because whenever a tape completes writing, it would mean that the header is at the end of the tape, and if in case you want to read the header again or the label again, it has to rewind the tape all the way to the beginning and then read it. So it is a little time consuming, but this is again a precautionary step that you could take, which would help you to identify if a tape is corrupted because of any SCSI resets that happen on your storage node. The next section is the remote host, and in the remote host the first option you see is the NDMP. So this option is enabled whenever you're configuring a device and as an NDMP device. This is again for tape drives whenever you are using the data mover on the NDMP service as the storage node. The next option is the remote user, and the password for the remote user. So this is generally used whenever you're using a data domain or an AFTD which is on a network share. And if that network share is governed by an authentication, then the respective remote user and password has to be given. So again, in terms of data domain, you have to mention the DDBoost username and password for the respective storage unit where this device resides. Next is the data domain configuration. So this is for enabling the DD boost over FC, and if in case you are using that option, you can go ahead and use this section for setting up those parameters. So these were the two important tabs for a networker device. It is important you understand these parameters so that you can better understand the upcoming videos wherein we will be looking at how to configure a tape drive, a jukebox, a data domain device. Thanks for holding on till the end. I will see you in another video. Goodbye.